Hello and welcome to Pentest blog. This is our second video in the series of exploit development. Uh, Today we will see how to get control of the EIP and get a code execution. Finally, we will get a reverse shell using shellcode. Before going in today's topic, we will quickly recap what we have covered in the last video. We have seen that our offset length is 516 and we can override the address of the ESP, which is finally used by the EIP. Nothing indifferent, just we have just added one extra function here, that with the name of helper. If we go through the main function, in the main there is a reference of overflow function, and the overflow function is being executed that we have seen earlier, but the helper function is only defined. There is no reference or it is being called, so it is unused function. So what we will do, we will use our EIP to jump into this address, so this function will execute. So first we will look this scenario. First we will compile the code. Here is our code, gcc 1.c. We will output it 1, okay, and gdb and the executable has been loaded. So first thing, let's generate our simple payload using Python 3. That we have already seen, like our offset is 516, plus we are overwriting the ESP with the B, and the rest of the code is C. So this is 180, and we are saving it to the pattern.txt, or we can say it input.txt. That should be okay. Yes. So what we will do, we will run the and getting input, and we have seen like the EIP has been overwritten by B. We have a function, like what's the name of the function that we have is helper. So p helper is residing in this address. We can also like do like this, info functions, and here be the helper is residing in this address. Okay, so what we will do, we will jump into this address, so the helper function will be executed. So we will copy this address and take a note of it. Control V, we will byte by byte. One thing, the address is being stored like in the stack in a little endian format, that is it will be reversed. We will talk about it in our later videos. Okay, so what we will do, And the very first thing that I want to discuss in this video particularly about the Python 3 version. So there is a huge difference between Python 2 and Python 3. So what we will do, like first A9 11 x40 x00. So this is the address of that function. We will set this to instead of b. So, and the print function will not work here. We have to use like import sys dot std out dot buffer dot write, and our crafted address that will go here. Let's see, string bytes like object. Okay, so this thing all we have to convert it into byte. So now it will, and we will see what has been saved. Okay, so it has been saved, and now we will see there is no pound.text that we have defined here. If this function will be executed, then there will be a file named pound.text. So what we will do, we will run it again. Okay, so we have generated our payload and we will run it. So run and our input, and there we can see like a new process has been executed using the touch binary. So if we list the files, there is pound.text. So this function has been executed. So like we can jump to any address inside that code. So what we will do, we will generate a reverse shell code. In this video we will use msfvenom to generate shell code. Change this input to our old format, and we will again this thing, and we will run again. X230, and we will use the ESP. So here our payload is being started. As we can see, 41 this is A, and this is the address where the payload is started. So it been shifting to 8 bits. So this address will finally become 8, and here our payload is there. So what we will do, we will first insert some knob slides, that is, and then we will set our reversal, and then we will jump to this address. So finally our reversal will get executed. Now we will generate our reversal using msfvenom. We will have to know our IP. So this is our IP address. Okay, we will save it for later use. So msfvenom -p for payload. We will use Linux and our 86, and then we will get a cell reverse TCP. We will use the reverse TCP cell, and we want to get back to local host, that is our IP will be there. So we'll copy this, and our local port will be 9001, and we will exclude the bad characters. In this case, only one bad character we want to exclude, that is null byte, and we want the format of Python. Let's see. And here is our cell code. Copy, and in this here we will exploit.py. Okay, and to print this we will import sys. So our final payload will be and everything will be in byte encoded. So x will first start with 16 nope slide, and then our cell code, and then we will 500 minus length of buff into 180. So this is our final payload, and we will print it using sys .std .buffer .write payload. Didn't added the address where to jump in. So this is the address. We have to craft it in a reverse order. So xa8 xed xff xbf a8 edffbf. It seems correct. What we will do here is we will save it. We will run it again. We will start our netcat listener lvnp 9001 that we have given in our cell code, and we will exit the gdb and again run it. run using payload, and let's see if we have our yes connection from this, and we can execute a command. We will talk more about exploit development in very depth in our later videos, but for now this is it. So this is it for this video. Keep hacking. All the best. Bye bye.